Now we're going to look at some more examples of composite function problems. These first ones that we are looking at are like numbers 1, 8, and 9 on your assignment for 3.4. Okay, so we are evaluating each of these composite functions at the given value of x. So for number 1, what we are doing is we're going to evaluate f of g of 1. So first we're going to do is plug 1 into the function g. Okay, so we plug a 1 into x, and so we get 2 over 1 plus 1, and that is f of 2 over 2. Well, 2 over 2 is just 1, so we get f of 1. So we evaluated g of 1, and we got 1. Now we're going to evaluate the function f at 1. So we're going to plug in a 1 for x for that function f. So we have a negative 1 squared plus 1. That negative applies after the squaring, so we have a negative 1 plus 1, so we end up with 0. We are going to evaluate f of h of 2. So first we will plug 2 into that function h. We get negative 2 times, replace the x with 2, plus 1. So negative 2 times 2, we get negative 4, plus 1. That's going to be f of negative 3. We evaluated h of 2 and we got negative 3. And now we evaluate f at negative 3. Plug in a negative 3 for x. Get negative out in front of negative 3 squared plus negative 3. So this time we're squaring a negative 3, so that's going to end up being a 9. But then the negative out in front stays there. Plus a negative 3, so that's just minus 3. So we end up with negative 9 minus 3, which is negative 12. Okay, now let's look at g of h of negative 3. So first we want to evaluate h of negative 3, and that's going to go into the function g. So we plug in a negative 3, and we get negative 2 times negative 3 plus 1. Negative 2 times negative 3, that's a 6, and then 6 plus 1. So we end up with g of 7. All right, so we evaluated h of negative 3, and we got 7 as the result. And so now we're going to take 7 and plug it into the function g. So we get 2 over 7 plus 1. So that's 2 over 8, which if we reduce that, we get 1/4. Okay, so let's look at this one. We are going to evaluate f of h of 3/2. So we're going to plug 3/2 into h, and then that goes into f. We get negative 2 times 3/2 plus 1. Evaluating that. Negative 2 times 3/2, well, those 2's are going to cancel, right? So those will cancel, and we'll just be left with a negative 3 plus 1. So we end up with f of negative 2. All right, so we evaluated h at 3/2, and we got negative 2. And so we now plug negative 2 into f. So f of negative 2, we get a negative out in front of negative 2 squared plus a negative 2. So negative out in front, negative 2 squared is 4, and then plus a negative 2, so we get minus 2, and that results in negative 6. These next problems are like number numbers 4 through 7 on your assignment. This time we have functions given to us in table format, and we want to find these function values. So for number 1, we're looking for f of g of 1. So g of 1 is the inside thing, so we evaluate that first. On the outside, well, g of 1, we go over here to g. Here is 1, x equal to 1. Well, when x is equal to 1, g is 6. So what we're going to plug in there is a 6. And now we look at the table for f. We go over to where x is 6 and return the value of f when x is 6, which is 2. Resulting function value is a 2. All right, let's look at the next one. F of g of 2. So f of, we gotta figure out what's gonna go in there. So we evaluate g when x is 2. Well, there is 2, and g is negative 2. So we plug in a negative 2. And then we look at f when x is negative 2. All right, we don't have any negative 2's in our x row. So that means that f of negative 2, it does not exist. So we say D and E does not exist because negative 2 is not in the domain of that function f. Okay. The next one, we want g of f of negative 1, not f, but g of f of negative 1. So this time we're going to look to that function f to start off with. So we go over here, we go to, well, there's x equal to negative 1, f is negative 2. So we plug in a negative 2 there. And now we look at g, go to where g is negative 2, or where x is negative 2, I'm sorry, x is negative 2, and that gives us a g function value of 0. So our result here is 0. So for number 4, we want f of g of 3. So we are first going to look at the table for g, and we go over to where g is 3. Well, it never equals 3. So there is no number no number we can put in there. So what we say is this is does not exist. It's not possible because 3 is not in the domain of g. All right, so let's look at number 5. We want g composed with itself. So g of 2. Okay, so g of, so we do the first one and we go to where x is 2, g is negative 2. So that negative 2 is going to go in here. And then now we have x equal to negative 2. We go to where x is negative 2 and g is 0. Okay, looking at the last one, f of 3, we've got f of, and the inside function is also f. So we first look at the table for f. We have x equals 3. That's going to give us a function value of 4. So we end up with f of 4. And we look for 4 in the x's, and we do not see one. So this is a result of D and E, or does not exist. This example is like numbers 1 through 3 on the assignment. We will make one change, and that is that we are not going to find domain. And we want to find the expression for f composed with g and g composed with f. Now let's find f composed with g. So f composed with g of x. So this time we're not plugging in a value for x, all right? We are just wanting to come up with a new function. So f, and we're going to plug in g of x, which is square root of x minus 3. In f, place x with square root of x minus 3. Meant to do that x square root of x minus 3 in red above. And then we've got the plus 1. Okay, so the plus 1 doesn't go underneath the square root. Okay, that's separate. And there isn't really any simplifying we can do here. So our final function, f composed with g, is 5 times square root x minus 3 plus 1. All right, now we're going to have g composed with f of x. So g is the outside function. So we're going to plug in f into the function g. So we're going to plug in 5x plus 1 to x in g. So we're going to have the square root of, for x we plug in 5x plus 1, and then we've got, from the function g, we have a minus 3. Combine that so we have just one constant term, so we get 5x, 1 minus 3, we get minus 2.